We wanted it to be easily removable, so we connected this to the servo with only one screw.
We decided to put this on the side so it could drive right up alongside of the cup.
We slowed the robot down so it would be easier to control. We have these large, high-friction wheels in the back that get a really good grip on the ground. On the front of the robot, we have these wheels, which are just free spinning for now. The two wheels in the back are powered by motors that are under here. So those go to each wheel and make them spin. We have a rev hub in the back here, and the rev hub is the thing that basically tells everything else what to do. So the rev hub is plugged into the motors, plugged into this battery over here that is powering the robot, and it's also plugged into this phone. The phone is basically like the brain of the robot. It communicates between the rev hub to tell the rev hub what to tell everything else to do. We can control the robot remotely with this phone here, which communicates to the other phone that is on the robot. These two controllers is what the driver controllers, the people controlling the robot, use, and they plug into this phone. This robot pouring coffee is actually designed to be driven by two people. For programming a robot, we use completely Java. So for this project specifically, we set up a servo named arm, and we set it to null, which basically means nothing. And then we set up something else, which is arm pose. Arm pose basically says what the tilt of the coffee pourer should be, and we set that to 0 for now. Then we set the arm.setDirection to forward, which basically means that the default direction that the motor will spin in is forward and not reverse. Then we have a while alt mode is active loop, which is basically asking, is the robot running? If so, then while it's running, we had to go through these two if statements. I'll also go through a lot of other stuff, but that's not related to this project. So the first if statement asks if the second driver is pressing the left trigger more than 80% down. If so, then we increase the position of the arm by 0.01, and we set the position of arm to the arm position, and then we sleep 50. Sleep 50 basically means that we take a break for 50 milliseconds, or 0.05 seconds. That is done because Java runs really, really fast. And so we didn't do that, the arm would just like spin pretty fast, and we want it to be a really controllable speed. The second if statement is basically identical to that, just kind of the reverse. It asks if the right trigger is being pressed instead of the left trigger, and if so, we decrease the position of the arm. This allows us to tilt the arm both ways.